Okay, so today we're going to hopefully get this to focus. We're going to do 2.3, and this is called zeros of polynomials. And it's still not focused, so let's see. There we go, that's better. Okay, so the first example, we're just going to go right into some examples. Everything that we do in 2.3 should feel like a review to you. Okay, you've seen all of this stuff before. So example 1, let's revisit long division. Okay, yeah, the least favorite kind. So let's say we have 6x cubed minus 16x squared plus 17x minus 1 divided by 3x minus 2. All right, we are going to, remember you got to decide what goes on the outside, what goes on the inside. So this would just be like a fraction bar. It's like dividing by 3x minus 2. So 3x minus 2 goes on the outside. You create your big division. Now we'll write it down in a second, but looking at our polynomial here, we should notice that it does go in descending order, which is important. It needs to be in standard form. It also needs to have a placeholder for every term. So if I started at x cubed, I need an x squared, I need an x to the first, and then I have my constant. If I was missing one of those terms, I'd have to put in a placeholder of 0. Okay? So we're going to see that in a little bit. So 6x cubed minus 16x squared plus 17x minus 1. Okay, so then we're going to ask ourselves, how do we take 3x and change it to 6x cubed? What do you have to multiply it by? 2x squared. So I'm going to line that up. I want to keep nice and organized. So I'm going to line this up. So I have 2x squared. And then we take that term and we multiply it through this 3x minus 2. So this is going to give us 6x cubed minus 4x squared. Now this is the important part you have to remember. When you are done multiplying, you are subtracting this entire term. So each one of these terms gets subtracted. So you're going to have to change those signs according. So my first terms cancel. If they don't cancel, I've done it wrong. I should go back. And now I just keep combining. So this is going to give me a negative 12x squared. And then you drop the rest down. So the 17x comes down and the negative 1 comes down. Once you're here, remember you start over. So then you ask yourself again, how do I take 3x and change it to a negative 12x squared? What do you have to multiply that by? Negative 4x. So then I'm going to have a minus 4x here. I take that minus 4x and I distribute to my 3x minus 2. And that gives me a negative 12x squared plus 8x. Again, you're subtracting these terms, so each one of these signs has to change. The first terms cancel, so I'm on the right track. This gives me, let's see, 9x. And then I drop down what's remaining, which is the minus 1. Once I'm here, I start over. I ask myself again, how do I take 3x and change it to 9x? Multiply it by positive 3. So now I take the 3 and I distribute to get 9x minus 6. Since I'm subtracting both of those terms, both of those signs change. This becomes a positive 5. I start again. How do I take 3x and change it to 5? What can you multiply it by? Nothing, right? You can't. What is this number? Do you remember? It's the remainder. Okay, so this is our remainder. So what I want to do is write my final answer now. So I have 2x squared minus 4x plus 3. And then remember, in long division, you would add your remainder. So I'm going to add 5 divided by 3x minus 2. It's the part of the fraction that's left over. And that is my final answer. By show of hands, how many people remember this? Okay. It'll come back to you after you try it a couple times. It's like that same pattern over and over again. I want to make a note, though, of a couple things. The polynomial must be in descending order. And, like I said, you use zeros if you are missing a term. Now, no one really likes long division. It takes forever. It's annoying. There's lots of places to make mistakes. It's just not a good time. Yes?
Let's say 16x squared wasn't there. Do I
Yep.
just put 0 or do I do 0x squared?
You would write 0x squared. Yep. And we're going to try that right now. So the one that everybody really likes is synthetic division. So this is going to be example 2, and we're going to do an example of synthetic division. Okay, so I have 4x cubed minus 20x minus 13 divided by x minus 3. So going back just for a second, I'm checking for two things. If my polynomial is in descending order, which it is, and I'm looking to see if I need any placeholders. Do you see in this one you're missing a term of x squared? Okay, so you're applying this idea here and to long division as well. So all of this gets applied to both of these things. So what I really need to use here is 4x cubed plus 0x squared minus 20x minus 13 divided by x minus 3. I have to change it and use that placeholder. Okay, so synthetic division is different because you only use numbers. Okay, there's no variables involved. And so I just want you to watch for a second me set this up. Okay, so the first thing you do is you think to yourself about what you're dividing by. So this x minus 3 is like a factor of this polynomial. So I take this, I set it equal to 0, and I solve. So that means that x equals 3 was the 0 potentially. Okay? So I take this 3 and I put it on the outside. I just want you to watch for right now, and then I'll do this again and you can write it down. Then you put like an upside down box. And you only use the coefficients in descending order with your placeholder. So it's like 4, 0, negative 20, negative 13. You drop down your first term, and then you multiply these together. So 4 times 3 is 12. Then once you get there, you add it. So 0 plus 12 is 12. Then you multiply. 3 times 12 is 36. And then you add to get 16. And then you do 3 times 16 is 48. You add 48 to 13 to get 35. This number is your remainder. If your remainder is 0, what does that mean? Do you remember? There is no remainder, and this is a 0 of the polynomial. It's a factor of it. Okay, so let's do this again. You write it down this time with me. So in order to do this, you figure out, you take your divisor, you set it equal to 0. Okay, So let's make a note of that. Use the zero of the divisor. Okay, so I take x minus 3, I set it equal to 0, I figure out 3 goes on the outside. So I put 3 on the outside, and then I drop down that upside down box. And then I use only the coefficients in descending order with placeholders if needed. So 4, 0, negative 20, negative 13. So I drop down the 4, and then I multiply those together to get 12. That goes there. And then I add to get 12, and I multiply to get 36. And then I add to get 16, and then I multiply to get 48. And then I add to get 35, and that represents my remainder. You with me? Any questions? So this is not our answer, okay, right? Because that doesn't make any sense the way it is. So what happens in synthetic division is every single time you do it, you drop a degree. So remember that this problem started with x cubed. I have to go down a degree, and I get x squared. So it loses a degree. So that's where I start. So this polynomial is like 4x squared plus 12x plus 16. And then I add my remainder. So plus 35 over x minus 3. Questions about synthetic division? Do you remember it? Yeah. So way easier than long division, way faster. So most of the time we're going to use synthetic in this chapter. Okay? Sometimes we won't. All right, let's keep going. So the remainder theorem. The remainder of the quotient is the value of the function. So for example, f of 3 was equal to 35. Okay, I'm referring to the previous example. When I took my function and I plugged in 3, let me find my paper. So when I took my function, which was this, and I plugged in 3 into it, so I did synthetic division with 3, I got a remainder of 35. This is the remainder theorem, okay? So when quotient, I don't know why I have all these big spaces, has a remainder of 0, it will be a 0, which is an X intercept, we know, of the function. So that's what we were talking about at the beginning. If I get a remainder of 0, I know that this is an X intercept of my function. The goal today is to be able to find the zeros of any polynomial that's given to us. And we'll have these tools. Like we already know how to factor. We already know how to do quadratic formula. We know how to complete the square. But sometimes you can't do those things. And so this is why we have all of this other fun stuff we're learning about today in order to find all these zeros. So we also have the rational zero test. So the rational zero test is used to find all possible rational zeros of a polynomial. We're going to refer to this as the RZT because it takes forever to write out rational zero test. So if we talk about RZT, that's what I'm talking about, the rational zero test. So you're going to need P, which represents the factors of the constant term. And then you're going to need Q, and that represents the factors of the leading coefficient. P divided by Q represents all possible factors. So let's do an example of this. Use the rational zero test to find all possible factors of f of x equals 3x to the fourth minus 5x cubed plus 2x squared plus x minus 12. Okay, so the first thing we're going to do is we're going to define P and Q. So P is the factors of the constant term. So here's our constant terms. This is P. Q is all of the possible factors of your leading coefficient. Remember, the leading coefficient goes with the highest degree term. So that means 3 is our Q value. Okay, so then I think about, okay, well, what are all the possible factors of P? So I take P, which is negative 12, and I think about all the numbers you could divide by, or divide into 12. So plus and minus 1, plus and minus 2, or 3, or 4, or 6, or 12. All of those numbers will divide into 12. Okay, now I do the same thing for Q. So Q is 3, so this list is going to be a lot smaller. So I could divide it by 1, or I could divide it by 3. Okay, now that I've found the list of P and Q, now I actually do the test. I figure out what are all the possibilities now. So you're going to divide these. So P divided by Q. So I'm going to do all of these numbers divided by 1. All of these numbers divided by 3. Okay, so I'm going to get plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 12. That's dividing them all by 1. Now divide them all by 3. I get plus and minus 1/3, plus and minus 2/3, plus and minus 4/3. 6 divided by 3 is 2, so I already have that accounted for. And 12 divided by 3 is 4, and I already have that accounted for. So this is the list of all of the possibilities. Okay? So that means that of this list, something in here could be a 0 of this polynomial. Okay? So this would be my final answer if it just said list all the possible factors. Did you do that last year? Yeah. So now let's figure out like why we do this. All right, I think I'm on example 4. Find all of the, let's just say all of the zeros of f of x. Actually, let's say this. Let's say find all of the real zeros of f of x equals x cubed plus 2x squared minus 13x plus 10. Okay, so anytime we are given a situation like this, we're going to go through the process. Looking at this right now, the very first thing you would try to do would be to factor, right? Because that is what we would know how to do at this point, right? So we would try to factor it, and the only way you could factor this would be to factor it by grouping. Agree with that? Because it's 4 terms. Okay, can you factor this by grouping? No, you can't. So now we have to have another method. Like we have to be able to find the zeros, so that is why we have the rational zero test. Okay? So this is our next step. If it doesn't factor, then we do the rational zero test. So let's just say step 1, try to factor. If not, do the rational zero test, the RZT. All right, so I've tried to factor it, doesn't work, so now I'm going to do the rational zero test. So the first thing I do is I define P and Q. So P is 10. So then thinking about the list of all of the factors of 10, you want to think about all the numbers that divide evenly into 10. So plus or minus 1, 2, 5, and 10. So far, so good. Now I think about Q. Q is the leading coefficient. That is 1. So this is a very short list. This is like best case scenario. Q was 1. So the only factors I have for 1 are 1 and negative 1. So now my possible rational zeros are going to give me P divided by Q, which is just going to produce the same list of P because I'm dividing all of those by 1. Okay, so that's step 1. Easy enough, right? When you're given a polynomial, you should be able to look at it and you should decide how many zeros are you going to get. So my question to you is, looking at this polynomial, how many zeros am I going to get? Nicola? 3. How did you know it was 3? The degree. So everybody agree that this has a degree of 3. It's the highest exponent. So the degree is 3. Therefore, you will get 3 zeros. So I know when I'm done, that's what I'm looking for. I'm looking for 3 zeros. Now, because we've done complex numbers, we know that some of the zeros could be imaginary. Okay? Some of them could be real. Now, we are only looking for real zeros in this problem. So we might not get 3 for our final answer, but 3 will exist total. They might be real, they might be imaginary. So let's go to step 2. Step 2, we're going to choose a possible zero from the list and test using synthetic division until you get a remainder of 0. I know when I get a remainder of 0, that means that it's a factor, that it's a 0, it's an X intercept, so I could stop. So looking at this, if I take a look at all my possible zeros, I have a possibility of like 8 of them. Okay? See my list there? P divided by Q, only have 8 possibilities. In the previous list, we had a lot more. So I got to pick one of those to try. Maybe I'll pick 10 for starters. Okay, so you just pick one of them at random. So I'm going to pick 10, and I'm going to do synthetic division with it. So remember, it's got to be in descending order. You want to make sure you don't need any placeholders. If you do, put them in, and then fill in your coefficients. So 1, 2, negative 13, and 10. And then you do synthetic division. So the 1 drops down, and we multiply to get 10. Add to get 12. Multiply to 120. Add to 107. Multiply to 1,070. Add to get 1,080. What does this mean? It's a no-go, right? It's bad. It's not a 0 because I didn't get a remainder of 0. So now I go back to my list. I pick another number that I want to try. I don't know what will work. Sometimes you're going to pick over and over and it's just going to keep not working. Sometimes you're going to pick it right on the first try, okay? Let's pick 2. So I do synthetic division again. So 2 is on the outside, and I have 1, 2, negative 13, and 10. I'm going to stop talking, and you're going to try to do the synthetic division on your own. So you drop down the 1, you multiply to get 2. You add to get 4, you multiply to get 8, you add to get negative 5, you multiply to get negative 10, you add to get 0. What does this mean? It's good. It's a solution, right? So this is good stuff. Because we got a remainder of 0, I know that that is a factor, okay? I know it's an X intercept. It's going to work. Okay, so now we're on step 3. Once you find a solution, then you can try to factor to find the remaining solutions. Or you can go back to the list and pick another possible 0 to try. So, in my opinion, I always try to factor it because it's faster, okay? So, remember how you set up your polynomial. So, right now this started at an x cubed. It's got to drop a degree. So, now I have x squared plus 4x minus 5. You want to try to factor it. Are you seeing that it factors to x plus 5 times x minus 1? Okay. So now, think about what that means. Remember what our goal is. Our goal is to find all the zeros. So right now, it's like this is set equal to 0. If I used the zero product property, I would get x equals 1 and x equals negative 5. Those are my other zeros, okay? So, if I would have chosen to do the OR option and go back to my list, if I would have chosen negative 5 or positive 1 and tried synthetic division with those, they would have worked as well. Order doesn't matter. It doesn't matter, like if you would have tried 1 first, you would have got it. And most people start at 1. That's why I didn't want to start at 1, because I wanted you to see what happens if it didn't work. But it doesn't matter, like if you chose negative 5 or 1 or 2 first, it would all work out the same, okay? Now, I want you to think about a couple things. The question said, find the real zeros, okay? So, if the question says find the real zeros, I just find x equals and then these values. So x equals negative 5, positive 2, positive 1. But I want them listed in smallest to greatest order. So 1 and then 2. If it said find the X intercepts, that answer would look like negative 5, 0, 2, 0, 1, 0. If it said give your answer in fully factored form, I want you to think about what that would look like. So what that's asking you to do is go back to the beginning and write this in factored form. But we didn't know how to factor it before, right? But now we know all the zeros. These zeros produce factors. So this would be like f of x equals x plus 5 times x minus 1 times x minus 2. And that would be considered fully factor form. This question said, give me the zeros. I'm going to write this better. So x equals negative 5, 1, and 2 would be my final answer. Okay, that's what this question was asking for. Any questions? Still not done. It's okay, we're having a lot of fun. I think this is example 5. Oh, not yet. Don't write that yet. I want to talk about something else first. What I want to talk about is the leading coefficient test. Or the LCT. And this is like last year when you talked about end behavior. And I know you did that last year. So let's make a table to organize our test. So we're going to look at a couple different things. We're going to look at when the degree is odd versus when the degree is even. We're also going to look at when a sub n is greater than 0, or otherwise when it's positive, that means the same thing. Or when a sub n is less than 0, or when it's negative. And I'm going to write a function in kind of crazy notation, okay? So I don't want you to get hung up on the notation. I want you to think about what it's talking about, all right? So I think I could fit it in here. I forgot to write it. So f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus a bunch of other terms and then plus a sub 0. So this is kind of intimidating sometimes, okay, because it's kind of weird, right? But all it's saying is, like, pretend like you had f of x equals 3x to the fourth plus 2x cubed plus 1. This is your a sub n, right? It's your leading coefficient. That's all it's talking about, okay? A sub 0 is just a constant term. That's just your number that stands alone at the end. And this is in descending order. That's your n minus 1. That's all this means. So when I'm referring to n, I'm talking about the degree. Okay? So the degree of your polynomial. So if your degree is odd and your a value is positive, for example, if you have like f of x equals 3x cubed, versus f of x equals negative 3x cubed. Let's just look at these two together. So an odd degree comparing a positive a versus a negative a. Think about what the graph does. You know what this does, right? You know what an S-curve looks like. That's x cubed. If it's positive, doesn't the graph just kind of look like this? Right? So in terms of the end behavior, what's happening is it's rising to the right and it's falling to the left. This is all you have to show me, is just arrows for this leading coefficient test. I know you used to write like as x approaches infinity, y approaches infinity. You don't have to write all that anymore. Okay, just write some arrows. So you could also say that it falls left and rises right. Okay, so the test for f of x equals negative 3x cubed, what happens here? What does this graph do? Doesn't it do the opposite? Right? It flips. So that means it rises to the left and it falls to the right. Okay, so you can write those words, you can draw those arrows. This is true for any odd degree. This could be x to the 5th, x to the 101. They'll all follow this pattern. Same thing with an even degree now. So let's think about that. So let's compare f of x equals like 3x squared compared to f of x equals negative 3x squared. So this one is a parabola. It points up on both the left and the right. So it rises both left and right. When you change that to a negative, doesn't it just fall to the left and fall to the right? It points down, right? It's a parabola that points downward. So it falls left and it falls right. Okay, so you've already learned this before. Now we're just going to kind of summarize it real quickly in a quick picture. What we're trying to do is we're trying to be able to graph without the use of a calculator. No matter what's given to us, we should be able to figure out what it looks like. So that's what I want to try to do last. This is example 5. So given f of x equals 2x times x minus 1 squared times x plus 2, sketch the graph. So every time you do this, for me, you're going to do 3 things before you start graphing. The first is you do the leading coefficient test. The second is you find the y-intercept. The third is you find the x-intercepts. And then once you do all that, you graph. Okay, so taking a look at this, the first thing I do is I do the leading coefficient test. So all I want you to do is draw a little axes and think about your leading coefficient. Notice that this polynomial is already factored for us. So it's like I have to think about what the leading coefficient is. It's not 2x. It's not x squared. What is it? Two x times x squared times x. Justin. 2x to the, not fifth, but the fourth. So let's think about y. If I was to FOIL this piece out and then multiply all this through, distribute everything, my leading coefficient, my highest degree term, would be 2x to the fourth. If I was to take the time to multiply this out, because I have 2x times x squared times x. That gives me 2x to the fourth. So that's what you're comparing there. You only have to do that when they give it to you factored. Okay, well, what's the pattern of this graph? What does it do? It's an even degree. It's a positive a. Compare it to x squared. What does it do? Doesn't it rise and rise? If you know the pattern of x squared, you know the pattern of any even degree. So now I find the y-intercept. To find the y-intercept, I set 0 for x. So y is going to equal 2 times 0 minus 1 squared times 0 plus 2. Simplifying, I get 0 times negative 1 squared times 2. Who cares what you get, because you get 0 times something. So doesn't that just mean that my y-intercept is 0, 0? Okay, next thing, I think about my x-intercepts. In order to find the x-intercepts, I would have to factor. But this is already factored for me, so it's like the hard part's already been done. So I set this equal to 0, and I think about what I would do next after I factored, which is to use the zero product property. So I'm going to take 2x and set it equal to 0. I'm going to take x minus 1 squared and set it equal to 0. I'm going to take x plus 2 and set it equal to 0. So I just use the zero product property. I solve and I get x equals 0. So one of my intercepts is 0, 0, which makes sense because I already got a y-intercept of 0, 0, so that's also an x-intercept. This x minus 1 squared, that just means like x minus 1 times x minus 1, right? I still only get x equals 1 when I solve this. Whether you do it twice or you do it once, you still get x equals 1. But there's something special about this 0. Okay, this is a double 0. This also has a multiplicity of 2. You're going to see that in the book. It's going to say, like, what's the multiplicity? It just means how many times does the 0 occur. So, like, this has a multiplicity of 1 because it only occurred one time. Since this was a double, it would occur twice. It has a multiplicity of 2. This last 0, I get x equals negative 2, but my intercept is negative 2, 0. This has a multiplicity of 1. It only occurs once. Now, there is something special about a double 0. Does anybody remember what it does to the graph? Jessica? It bounces, yep. So this, let's say when a double 0 occurs, the graph bounces off the axis. Okay. So at that point, I've kind of gathered my information. And now I want to graph. Okay, so let's see. Let's just count by, I think if we count by ones, we'll be okay. Alright, so once I got this set up, now I'm looking at all of the information I have. The leading coefficient tells me that I'm going to rise to the left and I'm going to rise to the right. So if my graph does not do that, I know I did it wrong. Okay, so double check that. It's a real quick check. Both sides of this graph should be going up when I'm done. I know I have an intercept of 0, 0. I know I have an intercept of 1, 0 and of negative 2, 0. I know that the graph rises and rises. So I know this should be going up. This should be going up. These are things that I'm sure of, right? I also know that I have a double 0 at 1. So where other intercepts are going to cross through the axes, that one's not. It's going to bounce off of it. Okay? So then what we're going to do is we're going to find what we're going to call our relative max and mins. These are not really where the max and mins are, but we don't have a calculator. Okay? So we are just going to do it this way because we're not using a calculator. So you're going to find the point halfway between 0 and negative 2. Okay, you're just going to find the middle point between that. So if I was to plug in negative 1 and evaluate, okay, that's what I want to find. So if I was to do that, I would get some point, I would plot it, okay? If I could find the actual minimum, I'd have to use my calculator to do that, okay? So I'm not going to do that for now. I'm just going to plug in negative 1. So I get a negative 2. I'm going to write it down. So 2 times negative 1 times negative 1 minus 1 squared times negative 1 plus 2. So this gives me negative 2 times negative 2 squared times 1. That's like 4 times negative 2. So I get a negative 8. So at negative 1, I should be at negative 8. This is going to be a relative minimum. I'm not certain that that's the actual relative minimum, but it doesn't matter because I don't have a calculator. Okay, so I know it does that. Then I do the same thing for these intercepts between 0 and 1. Okay, so that means I would have to plug in a half. I'm really running out of time, so we're just going to plot this here somewhere. Okay, so it's actually, the relative minimum is actually 0.366, 0.696. You wouldn't find that, but for sake of time, we're just going to plot that point. What I want to show you is this. It's going to come down and connect with that x-intercept. But what happens is it bounces off the graph. So right here, I would mark this on your paper. This right here is that double 0 we see. It is that bouncing that's occurring. Okay? Notice that the other intercept crossed the x-axis, crosses the x-axis. This one doesn't. Because it's a double, it bounces. Questions?